Welcome back to another episode of my proof series where I show you why certain things happen in mathematics. Today we'll be focusing on why the derivative of e to the x is e to the x. Okay, and we're going to use limits to solve. Okay, let's start with e to the x. Okay, now let's first of all, the limit equation looks like this. Okay, h is delta x. I use h only because I was taught with using h, but it's because sometimes if you have f of x plus delta x, people sometimes get confused when you've got delta x, and when it gets jumbled up, usually later on in complex equations. So I've got taught with a different letter altogether, so that's why I use h. This is the rule that I've actually seen in some books as well, so it makes sense. But on that note, this is the derivative formula. And when it says x plus h, that just means you replace the x with an x plus h. And on the fx, you just leave it as the x. And I'll show you that what I mean. So let's say we find the derivative of e to the x. The other side will look like, using limits, as h approaches 0 of e to the x plus h minus e to the x over h. See what I mean? It means the function, but the variable will be x plus h instead of x, and on this one it will be x, the same, just like this. Okay, so when you have, say, x to the power of 2 multiplied by x to the power of 2, it equals x to the power of 4, and that's because I'll write it here, x to the power of 2 multiplied by x to the power of 2 equals x to the power of 4, and that's because you add the powers. It's x to the power of 2 plus 2, which equals 4. Okay, so I'll actually just scroll that out because we don't need it, but that's what we're going to be doing here. We have an e to the power of x plus h, so we're going to split that up, and it's going to look like derivative of e to the x, because limits, h approaches 0, e to the x multiplied by e to the h minus e to the x over h. Okay. Now this bit, it actually gets easier from here. So you have e to the x and an e to the x. We can factor that out and bring it out to the front. That's what we're going to do. It's going to look like this. E to the x multiplied by e to the h minus 1 over h. Okay. Now, because e to the x, it's multiplied onto this, and it doesn't have a h in it, what I'm going to do is I'm going to bring it out to the front, because no matter if h is approaching 0, it's only going to affect anything with a h or a h. So I'm going to bring the e to the x out the front, and it's going to look like this. Because if you think about it this way, when we find the limit of this and then multiply it onto this, it'd be the exact same as finding the limit of this, because it's still we're still gonna have to multiply to this later, but it won't matter until we find as what this is as h approaches 0. Okay, I hope I didn't make that sound too complicated. But okay, so now we've got that. So we've got e to the x. We'll write the derivative of e to the x. Okay, and the limit as h approaches 0 of e to the power of h minus 1 over h. Now, that equals 1. All this equals 1 as h approaches 0. And I've shown that, I don't know if you can see my calculator very well, but I haven't put it on 0, because if I put it on 0, it's not gonna. You can't have divided by 0; it just doesn't work. So I've made h approach 0. It's as close as it possibly can be to 0 without being 0. That's what this means. But I haven't done that because I don't want to sit here typing zeros for days. But I've put a decimal and then 4 zeros and then a 1. And as just like here, e to the power of h minus 1 over h, I've got e to the power of 0.0001. I think. Anyway, you understand that I've made 0 close to 0. It's a very small number, and it comes out as 1.000005. So, and if I was to add another 0, or take away zeros, it brings the 5 up, and add zeros and it brings the 5 down, which means the more zeros I add, the closer and closer it gets to 1. Therefore, as h approaches 0, e to the h minus 1 over h equals 1. Therefore, it'll be e to the x times 1. Therefore, the derivative of e to the x equals e to the x. Thanks for watching. I hope you learned something. Have a good day.